Hi everyone, welcome to my channel. So in this video we will learn about laws of exponents. So we will start in 2 minutes. Okay guys? Okay, let's wait for 1 more minute and we'll start. Okay, I will present my screen in 1 minute. I'll just open and I'll present. Yes, I open it. I'll present it. Yeah, coming to here. Yes. So hope you can see my screen, right? Yes, of course you can see me. Yes. So I hope you all are ready. Okay, we'll get started. Before starting, I want you guys to be awesome in this session, okay? Okay, so let's start. Yes. So, good morning, good evening to one and all here. Today, we all are going to a big journey of laws of exponents. So, let's start with the presentation. I'll be explaining to you about this with the presentation and with the board. And I will also show you the board. Hope you guys can see. Yes, so let's start with it. Yes. So we are going to see about the exponents and laws. So first, welcome to this session, as I said, and this is Rushita Tatikonda who's going to explain you about the laws of exponents. So let's start. So before we start, I would like you guys to please take your textbook, your pencil case, and a rough note for this session. Okay, so we will start if you are ready. So, in your textbook, please open lesson number 13, page number 253, just after the last question of exercise 3.1. Okay, so first we will have an overview of all the laws. What are the different laws of exponents? Multiplying powers with the same base, dividing powers with the same base, taking power of a power, multiplying powers with the same exponents, dividing powers with the same exponents. And then the last one, which is numbers with exponent 0. So we are having totally six laws of exponents. So this one is basically for class 7. Okay, so before we start with the laws of exponents, first we will learn what are exponents, powers and base. So you can see the picture. 10, it's written 10 to the power of 9. It's written 10 to the power of 9. So now, before going to this, the number which is below a normal number, I mean, is bigger in size, I mean, font size, and is also having a number above it, that is called the base. Right, that's called the base. If you can see in the picture also, they're saying this is called the base. Now whatever number is above it, to the I mean to above of base, this is also in smaller size, and also it is called the exponent. Right, exponent it is called. Now both these full thing all together is called the power. Right, power, it is called the power. So as you can see the board, I'll zoom the board and once more. Yes, now we can see that 10 to the power of 9, whatever is in a prominent size and is also having a number above it is called the base. Right, and the number which is above the base and it is in a smaller size is called the exponent. So it is called the exponent and this is called the power. Understood? Yes. Now back to the presentation. The presentation, so it's saying 2 the power of. What does 2 the power of mean actually is? 2 the power of means how to read it. So 2 the power of means how you read it. The 10 to the power of 9. 10 to the power of 9 is how we read the number which you see on the screen and on the board. So 10 to the power of 9. Now, what is this power of and everything? That is 10 to the power of 9 means you're multiplying 10 9 times to get the answer. Okay. So when you multiply so now we will see what do you mean by that. Right, now let's take an example of a power. I mean power. So let's take an example that 3 to the 2 to the power of 5. Right, 2 to the power of 5, if you see, It is this is a number where this is the power, and 2 to the power of 5 means 2 multiplied 5 times, right? 2 is multiplied 5 times, which comes to 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32. So 32 is the answer. Understood? Yes. Hope you have understood. And let's go to the next one. Let's go to the presentation back. So, coming to the presentation back, now it's written that if the exponent is 2, I mean in the place of 9, if there is 2, then it is called as square. Understood? It's called as square. And if, right, if one minute. Yeah. So if 2 is there, then we should say it as 2 cube. I mean 2 square. And if 3 is there in the place of an exponent, then it is called, we have to say it as 2 cube. Understood? 2 cube. Now, we can see, now in the place of 5 over here, we write it 2, and another example 5 to the power of 3. Now you can call this one with the help of 2 the power of, or you can also say it as cube. This one as cube and this one as square, right? Square. So in this way you can say them. Now let's go to the next slide in the presentation. So coming to the first rule of the laws of exponents, right? Coming to the first rule of laws of exponents. The first, I'll present once more. First one is multiplying powers with the same base. Coming to that, first I'll explain you guys the what is the definition of it. Now, when numbers with the same base are multiplied, the power of the product is equal to the sum of the powers of the number. Now I will say you with the board. Yes, you can see the board, right? Yeah. So now what is being said over there is when the numbers with the same base. Now you know what's base. So when the numbers with the same base, 2 to the power of 5 into 2 to the power of 3 are multiplied, then the powers of the product, the powers of the product, the product of the powers, I mean whatever comes 2 into 2, this 2 into 2 will be always equal to this 5 plus 3. Understood? Yes, you'll not be able to understand with this, but with the next one coming, the statement is if a is a non-zero integer, a is a non-zero integer, and m and n are whole numbers. M and n are whole numbers. Whole numbers. Then a to the power of m, a to the power of m into a to the power of n equal to a to the power of m plus n. I mean n. Right? Now what are they saying? A is not 0. Right? A is not 0 and m is a whole number. You know what's a whole numbers, right? What are whole numbers? 0 to infinity are whole numbers. Right? Now let's take in this place only the same example, 2 to the power of 5 into 2 to the power of 3, which is equal to, now what have they done over here? The non-zero number is same written over here, they are not multiplying them, so these two should be written over here. Now what they did, m plus n, so m and n are exponents. As you can see, m and n are exponents, so in the place of m and n they have put 2 and 3. Now, what have they done, M and N? They have added them. They have added. Add them. Now, we're going to add 5 plus 3, which is equal to 2. 5 plus 3 is 8. So, 2 to the power of 8 is the answer. Understood? Yes, understood. Yes, you guys understood. So, now let's go to the example that's given on the screen. First, I'll show the example on the screen and then we will go. Right? Then we will go to the example. Just remove this. Yes. Now you can see on the screen the example that's given over here is 8 to the power of 3 into 8 to the power of 5. 8 to the power of 3 into 8 to the power of 5, and they have added 8. uh, I mean, they have kept 8 the same, right? And 3 plus 5, which is 8. So the answer will be 8 to the power of 8, right? Now I will explain you guys with some more questions. Some more questions. I'll explain it to you. Yes. Now I'll give you examples with two questions. So, first question, I'm taking it as 2 to the power of 5. Okay, let's take another number rather than 2. We'll take it 7 to the power of 8 into 7 to the power of 10. Now, this law will only function if the bases are same. Understood? Same it should be. So now let's do. Now, first always write this 7 to the power of 8 into 7 to the power of 10. Now, which is equal to. Now, here always you have to write the formula. The formula always you have to keep in your mind. Since a to the power of m into a to the power of n equal to a to the power of m plus n. Understood? And now let's just use this law. 7, 8 plus 10. Right? Right. Correct only. This part I've written it over here. and this part I've written it over here. Correct? Now 7, 8 plus 10, 18, and answer you've got is 7 to the power of 18. Right? These laws are some formulas or mental math that help you make the sums easier. Now let's go to the second sum that I'm having. I mean second question. Okay, the second question is 12 to the power of 20. Let's take into 12 to the power of 9. Okay? Now it's very simple, as you know. You guys know it, right? Now 12 into 12, I mean 12 to the power of 20 into 12 to the power of 10, I mean 9. So first let's write the formula. Since a to the power of m into a to the power of n equal to a to the power of m plus n, and so on. So 12 to the power of 20 plus 9, which is equal to 12 to the power of 29. Done. It's very simple. This is very simple. Okay. Now for multiplication, we have done adding of the exponents. Now for division, what are we going to do? Let's see in the presentation. Let's see in the presentation. So now let's go to the next one. Dividing powers with the same base. Now we are gonna divide powers with the same base. Now, when numbers with the same base are divided, the power of the quotient is equal to the difference between the power of the dividend and the divisor. Now, you will understand when you go to the next one. I mean, the next point, which is if a is a non-zero number and m and n are whole numbers, then a to the power of m divided by a to the power of n equal to a to the power of m minus n. Now let me explain it. Right, now you can see both. Yes, you can see both. Okay, so now what have they said in the first point? You leave it. You leave whatever they have said in the first point. You leave it, and the second point you have to concentrate on. So they are saying like a is again a non-zero number, and m and n are again whole numbers. So now the formula comes into the picture, which is a to the power of m into a to the power of n equal to a to the power of m plus n is what we have learnt before. Now this is for multiplication, this is for division. A to the power of m into, I mean, divided by a to the power of n equal to a to the power of m minus n. Understood? Yes. Yes. Now you will understand. Let's make this to solo. Yeah. Now you will understand. Okay. Okay. Now we are having two examples for this. Two examples for this one. So let's see them. Example is x to the power of 9 divided by x to the power of 6 equal to x to the power of 9 minus 6. 12 to the power of 10 and 12 to the power of 8 are divided, and 10 and 8 are subtracted. 10 is subtracted by 8 to the power, which is to the power of 12. Now I'm going to explain both of them clearly. Yes. So now you can use any variable also, right? Now x divided by x, but x is to the power of 9 and this x is to the power of 6. Now what have they done? They have done x to the power of 9 minus 6, which will be equal to x to the power of 3. This will be the answer. Now coming to the second example, I'll explain you with the third example also. Second example is 12 by 12, but the numerator is 12 to the power 12 to the power of 10 and 12 to the power of 8. Now what have they done here? 12 to the power of 10 minus 8, which is equal to 12 to the power of 2. Now this now divided is equal to minus the exponents. Okay, understood? Hope you did so. Now let's go to the third law. Third law of exponents, right? Third law of exponents, which is taking power of a power. If a is a non-zero integer again, a is non-zero integer and m and n are again whole numbers, a to the power of m whole to the power of n equal to a to the power of m minus n. Now what does this mean? What is power to power and what is this a to the power? And all I will explain. Now you can see here a is non-zero integers as we know. A to the power of n m. Okay, this is one power and this whole power has another exponent. This whole power has another exponent like 12 to the power of 2 whole to the power of 0. No, 6. Now what are they doing here? Now what are they doing here is you can see what are they doing here? They are doing a to the power of m minus n. Is it minus n? Correct. Into n. This is non minus n into n. Understood? Now here also we are going to do the same. 12 to the power of 2 into 6. Now what is this answer? This is the formula, so they'll not have answer. This is 12. 6 2s are 12 again. So this is the answer. Understood? Yes. Now for 10 power of a power, power of a power, I will put here. No. I'll write it. Now we will see some examples in the presentation. I'll move the screen to the presentation. Yes, you can see. This is the first one, this is the second one. So let's see this. 2 to the power of 3 whole to the power of 2. Now let's use the formula first. a to the power of m whole to the power of n equal to a to the power of m into n. Now 2 to the power of 3 whole to the power of 2 equal to 2 to the power of 3 into 2, which will be equal to 2 to the power of 3 on 3 to the 6. So 2 to the power of 6 is the answer. Understood? Now let's take the second example. 2 to the power of 3 and whole to the power of 4. Let me move your screen. Yes. 2 to the power of 3 whole to the power of 4. Now 2 to the power of 3 into 4, which is equal to 2 to the power of 3 fourths 12. 12. And don't forget to write the formula. Okay, don't forget to write the formula, which is this one. Understood? Yes, we have more 30 minutes. Correctly, I'll explain you guys the other ones. So other three will be explained in this 30 minutes. So till here, any doubts, you can just put it in the live chat. I'll respond to you guys, of course. Now let's go to the next one. Multiplying powers with the same exponents. If a is non-zero integer and m is whole number, then a to the power of m into a to the b to the power of m is equal to a into b whole to the power of m. Now let's get to explaining that one. Yes. Now, as always you say, as always we know a is non-zero integer and the formula is this. This is the formula, right? This is the formula, and we are going to see now examples. Understood? Okay, let me have, I'm going to explain them. I'm going to explain you guys with the examples. So let's see the examples. um let's see. Okay, let's take some number which is 5 to the power of 2 into 7 to the power of 2. So how are you going to solve this one? Is you are going to now multiply the base. So 5 into 7, which will be 35. And now you have to write the exponent the same. So the answer will be 35 to the power of 2. Now before doing this, you will also have to write a to the power of m into b to the power of m into a, which is equal to ab a into b to the power of m, or even ab to the power of m also will be written. So if there is nothing over between over here, it means x. I mean, it means multiplication. Okay, now let's take another example. Let's take it as 3 to the power of 7 into 12 to the power of 7, which will be equal to 3 into 12, which is equal to 30. So now you know we have to write the formula. So 12 to the power of 3 equal to, 12 into 3 equal to 36. Now write the exponent same over here, 7. This is the answer. Understood? Yes. Yes, now we will go into the next one. I will zoom in the presentation. Yes. Now let's go to the next one. The next one is dividing powers with the same exponents. We have multiplied powers with the same exponents, which we have multiplied the bases, and division. Now let's see. If a and b are non-zero integers and m is whole number, then a to the power of m divided by a to the power of b to the power of m equal to ab to the power of m. Okay, so now let's see about that dividing powers with the same base. Yes. So what is the meaning of that? Let's see. So when you are having same base, then what are you going to do? Let me exit full screen. Yes. So the formula is a to the power of m divided by a b to the power of m, which is equal to ab to the power of m. So now let's take an example of yes. Now you are going to do the same thing like the multiplication. You're going to do the same thing like the multiplication. In multiplication, you have multiplied the bases, right? Now in division, you're going to divide the bases. You're going to divide the bases, and that is what you're going to do. So now let's take an example, which is yeah, not having an example here. So which is, let's take 2 to the power of 5 by 7 to the power of 5. So now we are going to divide. Let's take it 6. 2 and 6. 2 divided by 6 is 1 minute. Yes, I think there's a network problem. 1 minute. Yes. So you're now going to divide them. 6 divided by 2, which will be 3 to the power of 5. So this is how you are going to do. Let me just present my screen once more. Yes. Now let's go to the next one. Hope you can see it. Yes. Numbers with exponent 0. For any non-zero integer, a a is to the power of 0 means always it is 1 only. Understood? Now you can see, now if a to the power of 0 equal to 1, then 7 to the power of 0 is also equal to 1, and then x to the power of 0. What do you think? This is also equal to 1. Right? Right. Now, now let's see, it's same like that, but let's have a different kind of example, which is 3 to the power of 0 plus 2 to the power of 0. Now what you're gonna do is 3 to the power of 0 is 1 plus 2 to the power of 0 is also 1. So 1 plus 1 is 2, right? 2. So this is what, when addition comes, whatever number which is having exponent 0 will always become into 1 1, and they will both together become 2. Right? Right. Now this was the last one that we had, and that's it. This is the ending of this one, this presentation, and today's video. So guys, so please practice these, and also how did you like it and everything you can keep in the comment box below or in the live chat. And also don't forget to do some things, and that's what I'm going to show you now. So I'm going to show you them. So, guys, don't forget to subscribe to my channel and everything. So, don't forget to subscribe to my channel, and also don't forget to click on the bell icon, okay? And also like, share, and comment. Like, share, and comment for this video. So, thank you everyone. Have a nice day, a lovely day, and bye bye.